Everyone, I am Dhanasekaran, Assistant Professor, Department of ECE. In this video, we going to see about double sideband suppressed carrier modulation. So let's see how it works. So these are the outlines of in this video. First, introduction, generation of DSB-SC signal, balanced modulator, advantage of DSB-SC modulation, disadvantage of DSB-SC modulation, application of DSB-SC modulation. So first we should know about double sideband suppressed carrier. So what is the definition of double sideband suppressed carrier? So is an amplitude modulated wave transmission scheme in which only sidebands are transmitted and the carrier is not transmitted as it gets suppressed. So here we only send the sidebands, so carrier is not transmitted to the another end. Okay, so DSB-SC is an acronym of double sideband suppressed carrier. Here the carrier does not contain any information and its transmission results in the loss of power. So in order to improve the power consumption in the transmission, so we have to suppress the carrier. By suppressing the carrier, we can reduce the transmission power. So thus only sidebands are transmitted that contains information. This results in the saving of power used in transmission. If you suppress the carrier power, so we can improve power consumption in the transmission. So in this slide we're going to see how the sidebands have the power and how the carrier going to be suppressed. So here the saved power can be inserted into the two sidebands. Hence we ensure the stronger signal that transmitted over long distance. So if you suppress the carrier, if you send the information with the two sidebands, we can transmit it over long distance of the transmission. So during the suppression, the baseband signal does not get affected in the any way. A normal system, also termed as a double sideband full carrier, that is if you see the signal that will have full carrier power, so along with the two sidebands. So what it results, the results will be the power loss. If you avoid this power loss, you should do suppressed carrier. So for overcoming this drawback, we use double sideband suppressed carrier system. So this is the generation of DSB-SC signal. Here we are having input of modulating signal for the product modulator, and the another one input is carrier, that is cos omega CT. If you give the both input to the product modulator, you will get the DSB-SC signal in the output, that is x of t cos omega CT. So as we discussed in the last diagram, so we can see the product modulator generate the double sideband suppressed carrier signal. The signal obtained by the multiplication of baseband signal, that is x of t with carrier cos omega t. By using the frequency shifting property of Fourier transform, you will get x of t cos omega ct is equal to 1 by 2 x of omega plus omega c plus omega minus omega c. So you know that a double sideband suppressed carrier meaning is only the two sideband components are transmitted, right? As for we discussed in this equation, we have only two components are present in the spectrum. So what are the two sidebands? One is plus omega c and another one is minus omega c. So this is a waveform of generation of DSB-SC signal, and the first one we have the modulating signal and the amplitude modulated wave, and the last one is suppressed carrier. You can clearly see that the suppressed carrier in this waveform. And the generation of DSB-SC signal, the suppression of carrier, that is if you see consider the baseband or modulating signal, The equation is x of t ax cos 2 fxt, and the carrier signal is c of t ac cos 2 by fct. And the mathematical representation of the signal output product modulator, the product modulator output is DSB-SC signal, that is s of t is equal to x of t into c of t. You will get further equation that the s of t is equal to ax ac cos 2 by fxt cos 2 by fct. You can use the cos a cos b formula. You will get s of t is equal to ax ac divided by 2 cos 2 by fc plus fxt plus ax into ac divided by 2 cos of 2 by into fc minus fx of t. So this is the bandwidth equation. The maximum frequency is fc plus fx and the minimum frequency is fc minus fx. Then the bandwidth is equal to f max minus f minimum. So you'll get bandwidth is equal to 2fx. The carrier suppression, that is the carrier without any information content, is suppressed by the balance modulator. The principle of balance modulators, how the balance modulators will work: when the two sidebands of different frequency are passed through the non-linear resistance, that is the non-linear will pass through the non-linear device, then the amplitude modulated signal with the suppressed carrier is achieved at the output. So what are the non-linear devices? So it can be diode, JFET, BJT, that possess non-linear resistance characteristics. So how non-linear device act as suppressing the carrier? That is the capability to produce two sidebands with the carrier, but a balance mode, the connection of two nonlinear device produce a DSB-SC signal. So let's have a look at the circuit balance modulator. Here we have the two diodes and the carrier signal, the input to the modulating signal, and the resistance, capacitance. Okay, the output is the V0 and the V1 and V2 here the dividend input. So as we can see that the baseband input signal applied at the input of two diodes. See here here diode 1 and diode 2, and after the diode 1 and diode 2 we will have a resistance and capacitance, right? So hence the input at the diode V1 cos omega ct plus x of t, and the diode 2 V2 is equal to cos omega ct minus x of t. So at the output side, tuned bandpass filter is obtained the parallel connection of RLC circuits. You saw that in the diagram itself. So I1 is equal to A V1 plus B V1 squared. The expansion of I1 is equal to A of x of t plus cos omega ct plus B of x of t plus cos omega ct the whole square. So finally we will get the I1 is equal to Ax of t plus A into cos omega ct plus Bx square of t plus 2Bx of t cos omega ct plus B cos square omega ct, that is A plus B the whole squared formula. Similarly I2 we get A into cos omega ct minus Ax of t plus Bx square of t minus 2Bx of t cos omega ct plus B cos square omega ct. So output voltage is V0 is equal to I1 into R minus I2 into R. The output equation you will get V0 is equal to R into Ax of t into 4Bx of t cos omega ct, and finally we will get V0 is equal to 2A R x of t plus 4B R x of t cos omega ct. Here 2A R x of t is the modulating signal and 4B R x of t cos omega ct is the DSB-SC signal. In the above expression we can clearly say the output voltage is the combination of modulating signal along with the DSB-SC signal. So here we eliminating the carrier, that is a suppressed. The DSB-SC signal is the passed through the LC component and received at the output. Will get 4b or x of t cos omega ct is equal to k into x of t cos omega ct. And the finally what is the advantage of DSB-SC modulation? So these are the three advantages. First one is it provides 100% modulation efficiency. Due to suppression of carriers, it consumes less power. Because of suppression, the power consumption is very less. If you add the carrier, you will get only loss of power. The last, it provides larger bandwidth. And we do have some disadvantage of DSB-SC system. These are the disadvantage of DSB-SC system. It involves complex detection process, and using this technique it's sometimes difficult to recover the signals because a bandpass sometimes may not work properly by using the DSB-SC signal to reconstituting the original signal. It is expensive technique when it comes to the demolition of the signal, so it's very expensive. And these are the three applications. During the transmission binary data, the DSB-SC system used in the phase shift keying methods, and mainly used in the television and FM broadcasting. DSB-SC signals allows to have a transmission that reduce the overall power consumption rate, so we can ensure that stronger signal at the output end we can transmit over a long distance. Thank you so much.